Example number 3 is a common type of problem that we see a lot. Well, they'll give you a rectangle and they'll have a diagonal drawn on it. And they give you some values here and want you to solve for a missing side. Now in this case, I'm still going to treat this just like if it's a right triangle. If it helps you to redraw this, you can. But just keep in mind, really this is just a triangle. And the diagonal is the hypotenuse. It is the longest side of your triangle. So I'm just going to highlight it to make it stand out that it is a right triangle. And I'm just really going to ignore this other side over here. Now sometimes what they'll do is they'll do something like, for instance, this 11 could be over here on this side, right? And they may not have it on this side up on the top. But notice this is, with it being a rectangle, this side is going to be the same as its opposite side. Just like x is going to be the same as this opposite side. So it's also going to be that x value. But what I'm going to do now is to label my A, my B, and my C value. Now I know I'm going to call this top one, I'm going to call this my A value. So my A is going to be equal to 11. I'm going to call X, I'm going to call that my B value. So B is going to be equal to X. And on the bottom, right, this diagonal that goes across is always going to be the hypotenuse, which is my C value. Now for some of you who are going, well, Mr. H, how did you know the top was A and this one on the left was B? It doesn't matter. You could have called the one on the left A and the one on the top B, and you'll still get the same answer. But what you can't do is mix up the C with an A or a B. And I knew this side was C because if I went to this right angle that I see in here, right, making this corner, because this is a rectangle, and I drew an arrow from it, it'll always point towards my C value, which is the hypotenuse. And the legs always attach to that right angle symbol. So let's go ahead and write our formula real quick. We have A squared plus B squared is equal to C squared. And in this case, I'm going to write the values that I know. I know that A is 11, so this becomes 11 squared plus my B value, which is X, so this becomes X squared, and that's going to be equal to my C value, which happens to be the square root of 202. And if this looks confusing to you, that they put a square root as an answer, that'll happen quite frequently, and there's nothing wrong with that. We're going to go ahead and we're going to square it as well, because right, it says C squared, so if this is the value of C, we also have to square the square root. Now I want you to keep in mind, I'm going to just show you reality, anytime there's a relationship between a radical and a square root. And this is a good time to talk about it so that this doesn't seem so confusing over here.
Can I get Justin?
So before we go any further, let's look into this idea that a radical and squaring something is basically the inverse of one another. So for instance, right, I'm just going to put on here, down at the bottom, tutorial, right? This has nothing to do with solving this problem other than I'm going to explain to you a relationship that you need to know if this looks confusing to you. So for instance, if I were to say 3 squared, right, which is basically equal to 3 times 3, most of you would tell me, Mr. H, that's 9. A lot of people remember what 3 squared is. Now, if I told you I wanted you to unsquare this 9, that may sound confusing. However, to unsquare the 9, we can simply just take the square root of it. For instance, if I were to tell you, what is the square root of 9? Many of you would tell me that it's 3. You would know this. A lot of you got this by memory. And that's because this radical undoes the squaring that had occurred when we put the little 2 on top. For instance, if I were to take the square root of 3 squared, what we actually started with right here to get 9, right? 3 squared is equal to 9. If I were to take the square root of 3 squared, it would just be equal to 3. So what we can say is, we can say that anytime you have a radical and you have something being squared, they cancel each other out. The same is true if we have a radical and a value being squared. In other words, here we have the squared number inside of the radical. Here we don't, right? We're squaring the radical itself. So in other words, let's say I had the square root of 9. If I were to square it, then this squaring would cancel out the radical, and all you would be left with would be 9. So this is just a mathematical rule. And hopefully that explains a little bit about what goes on with that relationship. And so now we're going to go ahead and continue doing this problem. But the reason I'm telling you this is because I'm going to put parentheses around here just to remind myself that I have a square up here. And that square right there, that 2, is going to cancel out the radical. And so therefore all we have left is 202 on that side. And on the left we still have 11 squared plus x squared. So now what I want to do is I'm going to move this 11 squared over to the right. I'm going to subtract it. Now notice I didn't evaluate it. I'm just leaving it as 11 squared. These cancel over here. And then minus 11 squared over here. And I don't know what that is, but I'm just going to put it in a calculator and it's going to tell me. So I'm going to get my calculator. And I'm going to do 202 minus 11 squared. And I'm going to hit enter. And it tells me it's 81. So this value right here is 81. And the only thing that we have left now on the left side is just the x squared. So what I want to do now is I want to take the square root of both sides. That cancels out the square on the x, and I end up with x is equal to, and I'm going to hit second x squared to get my radical symbol, and I'm going to type in 81 into it. And that gives me 9. And there's my answer. And keep in mind as you're doing these, right, anytime that you get a radical, you could get one for a leg. They might say this is the square root of 2. All right, this up here might be the square root of 7, right? Just go ahead and put it into your equation as is. But don't forget to square it. And remember, when you square it, all it does is remove the radical, and all you have left is the number that's inside, which we call the radicand.